Welcome back. The objectives of this video are to use the recursion formula. We'll find the sum of a finite arithmetic sequence, and we'll find partial sums of arithmetic sequences. So our first objective, using the recursion formula. When you know the nth term of an arithmetic sequence and you know the common difference, d, of the sequence, you can find the n plus 1 term by using the recursion formula, or the next term by using the recursion formula. So the next term equals the previous term plus the difference. You can use this provided you know the preceding term. For instance, when you know the first term, you can find the second term. If you know the second term, you can find the third term, and so on. So in our first sample here, we want to find the nth term of the arithmetic sequence whose first two terms are 2 and 9. We know the sequence is arithmetic, so the difference between 2 and 9 is 7. So we know our d is 7. And then we want to find the ninth term. So we use our formula for finding the ninth term of this sequence. A sub n equals 2, our first term, plus 7 times n minus 1, or listed over here. A sub n equals 2 plus 7n minus 7. We distributed the 7, so a sub n equals 7n minus 5. So our sequence is 7n minus 5. Since we want to find the ninth term of our sequence, we substitute 9 in for n, and we get 58. We've calculated the ninth term of that sequence. From having the difference in the first two terms, we can figure out what our sequence is, and then we can substitute in for whatever value we want to find. So our second sample, we want to find the 10th term of the arithmetic sequence that begins with 7 and 15. So we know our difference is 8. We substitute into our formula to find the sequence. Our first term is 7 plus our difference 8 times the quantity n minus 1, and we find that our sequence is 8n minus 1. And we want to find the 10th term, so we substitute 10 in, and we get 79. Objective 2, here we want to find the sum of a finite arithmetic sequence, adding up all the terms in that sequence. The sum of a finite arithmetic sequence with n terms is given by this formula. S sub n, or the sum, equals n, the number of terms, all over 2, times the first term added to the last term. And this only works for arithmetic sequences. So without a calculator, or without writing this out, find the sum of these terms, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So we notice there are 10 terms here. N is 10. And our first term is 1, and our last term is 19. S sub 10 equals 10 over 2 times 1 plus 19, or 100. So a checkpoint, we want to find the sum of these terms, 40 plus 37 plus 34, 31, 28 plus 25 plus 22. First term is 22. Our last term is 40. We have 7 terms. S sub 7, the sum of the 7 terms, equals 7 over 2 times 22 plus 40. 22 plus 40 is 62. 62 and 2 simplify to 31. And 7 times 31 is 217. Finally, our third objective is to find the partial sum. We want to find the nth partial sum of an arithmetic sequence can be found by using the formula for the sum of a finite arithmetic sequence. So if we wanted to find the 150th partial sum of this particular arithmetic sequence, 5, 16, 27, 38, 49. Yikes, we would need to find the 150th term of that. We certainly don't want to go and write this out and add it all up. So in order to do that, we'll use our previous formula. We see that our A sub 1 is 5. The first term is 5. Our difference is 11. Substituting into our formula, we get 5 plus 11 times n minus 1, and we get a sub n equals 11n minus 6. Our sequence essentially is 11n minus 6. So substituting in 150 for n, we get the 150th term is 11 times 150 minus 6 is 1644. To find the 150th term, we substitute 150 in for n. Our first term was 5. Our last term is 1644. 75 times 1649. I put that into my calculator, and I get the nth partial sum, or the 150th partial sum of that sequence is 123,675. We have used the recursion formula. We've found the sum of a finite arithmetic sequence, and we've found partial sum of arithmetic sequences. And you'll get some more practice with this when I see you in class.